Alright, and welcome to Altitudes of Right Triangles, Level 3. Now in this example, we have a more complicated problem where we're being asked to find the perimeter of the triangle shown below. And this is going to tell us having to find every single side. Well, our very first step in doing this is we actually have to find this side for dB. So let's see, what's our trick here? When we have a right triangle and there's an altitude being drawn through that right angle, we know that the altitude is the geometric mean of the two base segments. So let's go ahead and put an X for line segment DB. Now, if you'll recall back to our levels 1 and 2 videos, in this case we can do 10 times X, so let's write that out, 10 times X is equal to, and ask yourself, what is it that we always do with the altitude? Well, of course, we want to square it. Now from here, we're going to have to say, okay, well 10 times X is truly 10X, and that's going to be equal to 8 squared, which is 64. Now in order to get the X by itself, of course, we divide both sides by 10, and that goes away, and we're left over with this. X equals 6.4. If you know your rules of dividing by 10, if there's a decimal right there, it moves one place to the left when you divide by 10. That can be done in your head. Now over here, let's go ahead and start kind of tracking these things. So we know that X is 6.4, and I'm just going to do this math in our head. If DB is 6.4 and AD is 10, well, what is 6.4 plus 10? That's going to be 16.4, and in this case, inches. That's AB. Let's go ahead and find out what is CB. And let me go ahead and change colors for this just so this distinctly sets out. We're going to take a look at this triangle right here and understand this is actually a right triangle. So we know that X was equal to 6.4, and we know that this side is 8. And so when finding this length CB, we know that we're actually finding the hypotenuse. Let's call this Y. And in order to do this, we're going to have to use the Pythagorean Theorem. We're going to have to say, okay, 8 squared plus 6.4 squared is equal to, and notice I labeled CB as Y, so let's write Y squared. Now, this first part's pretty simple. What is 8 squared? Well, we know 8 squared is going to be 64. Plus, however, this next part you will need your calculator, and what is 6.4 squared? Which is really saying 6.4 times 6.4, which would be 40.96 is equal to Y squared. So 40.96 plus 64 will give us 104.96 is equal to Y squared. And ask yourself, what is it that we do in order to get rid of a square? Well, the opposite of a square is a square root. And if you're using your phone calculator, we'll turn it to the side, find the square root, and it turns out the square root of 104.96 is 10.24. And that will equal Y, or in this case, CB, which we'll call 10.24 inches. Now notice my space is getting a little bit limited. That's okay. Let me change colors here. Let's go to this very deep purple, and we have one more right triangle that we have to find the side length of. So take a look. We have this right here, and for this triangle we have a side of 10 and we have a side of 8. So let's go ahead and call this side Z, and when I notice, if I draw an arrow through this right angle, it turns out Z is also the hypotenuse. So this is actually pretty easy as well. We can go ahead and say 10 squared plus 8 squared will equal Z squared. Now, because I'm running out of space, let's just kind of talk it out. 10 squared is really 100 plus 8 squared, which is 64. And 100 plus 64, well, that's simply going to be 164, is equal to Z squared. So the question you have to ask yourself is, well, how do I get rid of a square? And just like in our previous example, we want to take the square root. So Grabbing my calculator, let's see. The square root of 164 would be 12.81. And so we know that z will equal 12.81. And so I'll come over here, and that was really side length AC, which will equal 12.81. Now let me change to one final color here. Man, we're just using every single color in the book here. And let's go with this UT burnt orange. And notice this. In order to find the perimeter, we simply have to add these three numbers. So if I were to add 16.4 plus 10.24 plus 12.81, what would I get? So using my calculator, 16.4 plus 10.24 plus 12.81 gives us this number, 39.45 inches. And this is in fact the perimeter, or aka every single side of this triangle added up, and this is our answer. Go ahead, pause this video, finish taking any notes that you need to, and let's go ahead and move on to example 2. Okay, and here we have example 2. Kind of the same as the last one. It says find the perimeter of the triangle shown below. However, you'll notice this is different in that it has an algebraic expression added in for this line segment AD. Now this really doesn't change our setup, so let's kind of review. Remember, we know that the altitude of a right triangle is always going to be the geometric mean of the two bases. So what does that mean? It means we'll take our two base segments and we will multiply them together. Now I think it's easier to put the single term in front, so we'll do 3 times x plus 6 close parentheses is equal to, and ask yourself, what is it that we always do to the altitude? Well, of course we know that we have to square it. So when solving this is fairly straightforward. Anytime we have a number outside the parentheses, we know that we have to distribute. 3 times x will give us 3x, and 3 times 6 will of course give us 18. On the right side, this is something I would encourage you to memorize. What is 12 squared? And that is 144. Now moving forward, what do we have to get rid of first? The 3 or the plus 18? And in this case, we have to get rid of the plus 18 by subtracting 18 from both sides. Now that zeroes out, and we're left over with 3x equals, and let me grab my calculator, just because I want to make sure that we're, being very, very thorough, and 144 minus 18 will give us 126. Now from there, we want to divide both sides by 3, and it turns out 126 divided by 3 will give us 42. So in this case, we can say, hey, x is equal to 42. And this is quite a long segment that we have here. So let's go ahead and continue on in this blue color here, and let's just go ahead and write out AB. So we have line segment AB is equal to, and you know what, I'll even go ahead and let's plug this 42 in. We know that x is 42 plus 6, and then of course plus 3, because we're adding these two segments together. So 42 plus 6 plus 3, if you just use your calculator, you'll find out that AB is equal to 48 plus 3, which would be 51. And so AB is 51 inches long. And that seems crazy. This is clearly not drawn to scale. Alright, now I'm going to switch over to red, because we now want to find the length of CB. And this is relatively straightforward. We know that it forms a right triangle, and let's call CB the letter Y. And so in this case, when solving for Y, when we have two legs of a right triangle, we know we simply want to use the Pythagorean Theorem. So we'll do 12 squared plus 3 squared is equal to, in this case, y squared. So once again, what is 12 squared? Well, we know that that is 144 plus 3 squared we know is 9, is equal to y squared. And what is 144 plus 9? Well, that would be 153 is equal to y squared. And in order to get rid of a square, what do we have to do? Well, the opposite of a square is the square root. And this is something that you will need your calculator for. This is a-okay to use it. And so you can flip your phone sideways, and we'll type in 153, hit the square root button, and we'll see that y is equal to 12.37. Okay, now remember y is technically CB, which is equal to 12.37 inches. Alright, let me go ahead and switch to one more color. We'll go with this nice deep purple. And now we're actually going to look at this right triangle here on the left. So, if you will recall, we had x plus 6 as one of our sides. And we know that x plus 6 actually was this right here. X plus 6 gives us 48. So we'll do 48 squared plus this leg right here, 12 squared, is equal to, and for this side AC, I can even go ahead and write AC over here. Let's call that side Z. And when you go through the right angle, we know that this side opposing the right angle is still going to be the hypotenuse. So in this case, Z squared. Alright, so let's go ahead and grab our calculators and get prepared for some very big numbers. 48 squared, or aka 48 times 48, is 2,304, plus, we know 12 squared is 144, and this is equal to Z squared. And what is 2,304 plus 144? Well, that would give us 2,448 is equal to Z squared. And how do you get rid of a square? Well, of course, we will take the square root of both sides, and it turns out that Z is going to equal 49.48. And so I can come back over here to AC and write 49.48 inches. Now notice, when you're talking through this, we're trying to find the perimeter. So let me once again go back to this kind of almost UT burnt orange. And for the perimeter, you simply have to add all three of these numbers. So I'm going to go ahead and clear myself off a nice little space here. And let's see. What is, get my phone oriented, 51, which was our AB, plus 12.37, which was CB, plus 49.48. And this will, of course, give us the answer, which is 112.85 inches. And what is this number that is our answer? Well, it's the perimeter. It's the distance all the way around the outside of this triangle. And as you can see, I'm just drawing these multiple laps. That is how many inches around that triangle it is. I hope this helped. Pause the video to finish off any notes that you have. And good luck on this level.